Hi everyone, it's Mrs. Woolley. Thank you for joining me. Today our I can statement is to estimate square roots of perfect squares. So our agenda is to complete the do now and to complete the class notes and to check last night's homework. I want to remind you to please pass in all your homeworks on Monday so I can give you full credit. Tonight your homework is 1.3 homework. What I'm going to ask you to do is to stop the video and please complete the new do now. And when you are done, you can restart the video and join me. So in Google Classroom, you should access your 1.3 class notes students copy, and you should fill in the notes as I'm going through the Google Slides presentation. So numbers such as 1, 4, 9, 16, and 25 are called perfect squares because they are the squares of integers. When we find the square root of a number, we are performing the inverse operation of squaring. So squaring and square root are inverse operations. We're going to look at the concept of square root. Every positive number has two square roots. A positive, which is also called the principal square root, and a negative square root. So the square root of 25 is 5, since you are multiplying 5 by itself twice, or 5 times 5 is 25. The square root of 25 is also negative 5, and this is referred to as the negative square root, because negative 5 times negative 5 is also equal to 25. Now, what is the square root of negative 25? So think what number is times itself is equal to negative 25. There is no real number. You cannot multiply the same number by itself and have a negative product, because negative 5 times negative 5 is 25, just like 5 times 5 is 25. So there is no real number you can multiply by itself to make a negative 25. So I'd like you to take a look at the symbol for the positive square root. And in this example, the square root of 144 is equal to 12. And then if you notice the symbol for the negative square root, it is outside the Radican symbol. So the square root of 16 is 4, and the opposite of that is negative 4. And I apologize. My dogs are very upset at something that is outside. So if we want to show both the positive and the negative square root, we can write this plus or minus, which would be plus or minus 7, or we can write it like this. So I'm going to ask you to try the simplified problems, and then we'll go over them together. So you might want to turn your video off for a moment. So in example 1, the square root of 144 is 12, and I'm going to take the opposite of that, so it is equal to negative 12. On the second example, I'm looking for the principal and the negative square root of 121, so it is equal to 11 and negative 11. And you notice I could write it like this. I could also write it like this, but it would be equal to negative 11 and positive 11. In example 3, this is pretty tricky. When you don't see an operation between a number and this square root, it is multiplication. So this is 4 times the square root of 36. Well, if the square root of 36 is equal to 6, and 4 times 6 is 24. This last example, you're going to simplify each of these each of these square roots and then add them together. So the negative square root of 81 is equal to negative 9, and the square root of 49 is equal to 7. And negative 9 plus 7 gives you a sum of negative 2. So the big idea is that square roots can be both rational, or which Yesterday we learned rational means fractional or ratio, so they can be rational numbers or irrational numbers. So perfect squares are numbers that are squares of a whole number. And the square roots of perfect squares are always rational numbers. So examples would be 1, 4, 9, 25, 225. Non-perfect squares are numbers in which the square roots are irrational numbers. So 2, 65, 229. So if I was to take those square roots, they would be irrational numbers. And remember, irrational numbers are non-terminating and non-repeating decimals. So at any point in the video, you can always stop it and complete the notes. So don't feel rushed. That's the nice thing about a video. You can always stop it and you can also replay it. So I'm going to ask you to memorize these perfect squares. They're the first 25 perfect squares. They are the most common perfect squares that you will see. So I'm going to ask you to really concentrate right here on 1 through 15, and then the square root of 400 and the square root of 625. Once you master those or memorize those, you can look at these more challenging ones. This will help you not only this year, but in your future math classes when you take the PSATs and the SATs. So we're going to look at the square root of 50, and we're going to try to use perfect squares to help us determine what the square root of 50 is between. So I know that 49 is a perfect square, and I know that 64 is a perfect square. So between those, when I take the square root of those two numbers, I get 7 and I get 8. And so I know the square root of 50 is between 7 and 8. So if you and that's a great estimate. If you think about the number 50, it's closer to the number 49. So if we took the square root of 50, it would be closer to the number 7 on the number line. So I'm going to ask you to watch this video, and I have also attached the link in today's material. And I think it will help you use the number line and your knowledge of perfect squares to estimate non-perfect squares to the nearest 10th. So the process for finding a estimate to the nearest 10th of the square root of 52 is to find the nearest perfect squares on either side of the number line and use a number line to help you visualize this. To take the square roots, to use this information to help you refine your estimate to the nearest 10th, and to check your estimate by multiplying. Now, I'm going to post another video that will help you with this example, and hopefully you'll be able to use that example to help you with your turn problems. And when you're done, I'm going to ask you to try some MCAS problems. And I want to remind you that the key is posted. The teacher notes are posted for you to take a look at. Thank you for watching this video. I hope it's helpful. Please write down any questions that you have about any of the material, and we'll go over it when I see you on Monday. Thank you so much, everybody.